Hello everyone and very welcome to the channel. No matter how much I respect the innovation which NVIDIA has brought in when it comes to generative AI and all the hardware around it, but I still believe that monopoly is never good. That is why I am always in for any project that promises to break the monopoly of any company. That is where this new project called as Felafax come into play. The thing is that right now, more than 90% of large language model workloads run on NVIDIA's GPUs of every kind. But as we know, there are various other alternatives available for GPU which are not only quite performant but also way cheaper too. The problem why there is not much adoption of other GPUs architecture is that the software is still lacking. Now, the problem is that, for example, training and serving Llama 3.1 on Google TPU is about 30% cheaper than NVIDIA GPU, and there are various benchmarks, papers, and research around it. And as I said, the major problem why these TPUs, why AWS Trainium, why AMD ROCm is not being adopted is because that the developer tooling for non-NVIDIA chipset is lacking and lacking big time. It's a huge pain out there. That is where this new project Felafax tries to help. What it is trying to do is that it is translating models from from PyTorch to JAX. JAX is a Python library for accelerated oriented array computation and program transformations, or in simple words that it enables you to run your AI workloads or LLM workloads on TPU or tensor processing units. Also, it uses XLA behind the scene to compile and run your NumPy program on GPUs and TPUs. XLA is an open source machine learning compiler for GPUs, CPUs, and ML accelerator. But I'm not going to go into further detail of XLA and JAX because those are separate topics and I already have covered them in my previous videos. So coming back to this Felafax, it is a framework for continued training and fine-tuning open source large language models using XLA runtime. What this Felafax does is it takes care of necessary runtime setup and provides a Jupyter notebook out of the box to just get started, and I will show it to you shortly, which you can also access it from their GitHub repo page, and I will drop the link to it in video's description. The cool thing about this Felafax is that it is pretty easy to use. It also easily configures all aspect of your training because it is designed for ML researchers and hackers. So if you are a common user, this might seem a bit daunting, but if you are ready to learn, I think it's a great way to learn some of the fine tuning on TPUs. Also, you can easily scale your training from a single TPU virtual machine with 8 cores to entire TPU pod containing 6000 TPU cores. You can get started on Google Colab free TPU, but that is going to take more than 12 hours, and I will show you how to do that. But if you are really doing it in a production environment or for a serious project, I would highly suggest that you go with some of the good GPUs, like with good TPUs with plenty of memory. Now, another thing which there are few limitations, of course. For example, there is no inference execution sample at the moment. You cannot upload it to Hugging Force as such because everything is in the memory. It is simply a sort of a construct in the memory at the moment. But still, I think a very early project evolving quite rapidly, as I can see. So I'm more than sure that these deficiencies will be resolved very soon. So now let me take you to its Colab, which you can access it from their repo. So if you look at this Colab, it's very simply written. I'm not going to run it because it is going to take 12 hours and I can't really wait for 12 hours to it for it to finish. So if you look at, first up, we are just installing this Felafax with pip, and then we are uninstalling and installing the TensorFlow CPU here. From there, we are specifying that okay, we are not going to use CUDA visible devices, and from there it is just importing some of the JAX libraries, and I already told you what JAX is, and then it is loading some of the modules, and all those modules are related to Felafax. Once that's done, we are just giving the new name for our model, which will be JAX enabled, and these are the some of the hyperparameters around low ranked adaptation, its rank, its alpha, its data type, and model has been downloaded. This is a data set which of course you can grab any one of your own choice, but for this one, this is using the alpaca format, and from there it is just giving it the prompt template, defining the prompt, defining the tokenizer, what are the input token, any loss mask, and you can see that it is not that easy to understand because there are a lot of things happening around bit of a low level where numpy arrays with JAX and XLA are being done. For example, if you look at this code chunk in a machine, in a bit more technical lingo, what it is doing, it is primarily using XLA to compile and run your NumPy program on TPUs, and compilation is happening under the hood by default, with library calls getting just in time compiled and executed. Also, JAX all lets you just in time compile your own Python function into XLA optimized kernel using a lot of different functions like JIT and few others. But you can dig deeper if you like. And then the data set is being downloaded, and this is where it is being split into training and test data set. These are the data loaders, and if you want to run and test your own data pipeline, you can check it out from here, but for the purpose of it, you can simply go with this, where it is defining some of the learning rate and how many epochs or how many passes it is going to make on the data set, maximum steps, and all these hyperparameters related to training. This is a usual optimizer which is being used. This is the data set is which is being prepared with the limits and stuff, and you can print it out. This is the usual trainer which is using the causal LM trainer, and this is where training is being run. So this is how you can simply run it with your own data set, and it is going to produce a JAX model which you can readily run on your TPUs. So still I think long way to go, because if you compare it to NVIDIA's GPU based fine tuning and training, that is far more easier, quicker, and easy to understand, and seems that it is quite solid at the moment. This also seems quite good to me, not bad at all, but I think long way to go, badly needed to make it more developer and friendly, because this is exactly the reason why AI has really taken off, because it has become so accessible to mere mortals like us instead of going into the nitty gritty. So I will drop the link to this Felafax in video's description. Let me know what do you think. If you're already using TPUs, please share your experience, especially how do you compare it to NVIDIA GPUs, how much cost benefit you have witnessed. Really keen to know more about it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.